In this video, I'm going to explain how to calculate the molar mass of a really complicated looking molecule. This molecule has a parenthesis with a polyatomic ion. That polyatomic ion has its own subscript, and it's affected by another subscript on the outside. The hardest part about this type of problem is correctly counting the number of atoms you have. So the preliminary steps are exactly the same as any other molar mass problem. The first step is to write down each of the atoms. So I see magnesium, P for phosphorus, and O for oxygen. Then what I need to do is look on the periodic table and find the mass of each of these elements. So I'll use my periodic table and find the mass. 24.30 for magnesium, phosphorus 30.97, and oxygen 16.00. Each of these numbers came from the periodic table. Pretty simple so far. The next piece is what's hard for this type of molecule. We need to multiply by the number of atoms of each type. So let's break this down. The first thing I see is a subscript of 3 next to magnesium. That multiplies by the magnesium, which means I have 3 magnesium atoms in this molecule. The next piece is looking at the phosphorus and oxygen. The first thing that we want to do is look at the subscript that's on the outside of the parentheses. That will multiply times everything inside. So it's going to multiply the phosphorus times 2. There's no other number affecting phosphorus, so that means it's just 2 of those P's for phosphorus. Oxygen already has a 4. This is multiply those subscripts by the element. So in the case of oxygen, we're going to take that 4 that's already there and multiply it by the 2, the other subscript. Anytime you see these 2 subscripts, you're going to multiply them together. That will give you the accurate number of oxygen molecules. In this case, oxygen atoms. In this case, we have 8. So when we do these calculations, we'll type it in the calculator. 24.3 times 3 gives us 72.9. Phosphorus, 30.97 times 2, which gives me 61.94. And finally, 16.00 times 4 times 2. So I have a mass of 128.00 for that oxygen. The last step is to add all of these together to get the final molar mass of this whole entire molecule. So I'll take my 72.9 plus 61.94 plus 128. Which gives me a molar mass for this magnesium phosphate molecule of 262.84 grams per mole.